This is numbers 13 and 14 on the study guide. Number 13 is a proof, and they filled it out for us. So if you look, the very first statement matches the given, so this has to be given. In the second statement, what they did was they multiplied both sides by 3. When they multiply this side by 3, the 3's would cancel, leaving us with 2x minus 6. When they multiplied this side by 3, we got 18. So when you multiply the same thing on both sides, that's the multiplication property of equality. The next step that we do is we add 6 to both sides. When you add this 6, it cancels. When you add 6 this way, you get 24. So when you're adding the same number to both sides, you're now using the addition property of equality. In the next problem here, you're going to divide this 2 on both sides. The 2's will cancel here, leaving us with x. And 24 divided by 2 is going to give us 12. So that is the division property, since we divided the same thing on both sides of the equation. The last one here, you'll notice that 12 equals x is now x equals 12. We flip these positions. When you do the flipping, that is something called the symmetric property of equality. On number 14, we are given this statement, and that's what we always start with, is our given statement. So y equals mx plus b, that's your slope-intercept form. And now number 2, look at our end goal. Our end goal is to isolate this m. So maybe the first thing we should do is go ahead and think about the order of operations backwards. Whenever you solve an equation, you go backwards. So looking at the m, it's being multiplied by the x, and it's being added by the b. So which would we take care of first, the multiplication or the addition? Well, going backwards, we'd take care of that addition. So we've got to move the b first. Since this is positive b, I need to subtract it from both sides. So if I subtract it from this side, it looks like y minus b. If I subtract it from this side, the b's will cancel, leaving me with just mx. So what I did was the subtraction property of equality. The next thing that I see is that m is being multiplied times this x. We've got to get rid of that x. So if we take that y minus b equals mx, and we divide both sides here by that x, we will have x on this side and m on this side alone, because if I divide this side by x, they will cancel. So that right there, we divided both sides by x, is the division property of equality. The last thing that we see is that our proof statement is not exactly the same, so we do need to flip it. So m is equal to y minus b over x. When you flip a statement like that, that is equal to two different things, again, that's the symmetric property of equality.